G'day and welcome back to RC Model Reviews. Now this is a video lots of people have requested. I'm going to talk about thermals because without thermals you can't do this. Thermal soaring, and there are a lot of models out there that rely on thermals. You've got discus launch gliders, you've got things like the Radian, the Park Zone Radian, big power assisted thermal soarers, and even the good old AXN can thermal soar. I think I've had about 30 minutes out of an AXN from about a 10-second motor run thanks to thermals. So I'm going to talk a little bit about what a thermal is today, how to spot them when you're flying, and how to make best use of them if you're trying to stay up without the use of batteries or fuel of any kind. Right, so let's get started. What I'm going to do is I've drawn a superb picture, as you'd find in an art gallery, of the sun up here and the ground down here. That's what happens. Sun, ground. Now, obviously, fine sunny days, you're more likely to find thermals than at night or on really dark, overcast, cloudy days, but thermals actually can happen any time. They're just more likely in the sunny, warm days of spring, summer, and early autumn, or if you're in America, fall. Right, what happens is, here's the ground, there's the sun. Now, usually the ground is not just a continuous, consistent color or texture or type of surface. We have grassy fields, we have plowed fields, we have roadways, all sorts of things, and they absorb the heat of the sun at different rates. So let's assume here I'm going to draw a plowed field here in the middle of our grassy countryside. Hope you can see that. That's brown. That's the plowed ground. Now, as the sun radiates its sunly goodness down onto the surface of the earth, different surfaces will absorb that heat at different rates, and they will actually warm the air above it. I'm going to draw the air now, because you don't see this very often. This is thanks to the magic of computer simulation. Here is the air sitting above the ground. Now, in the morning, first thing when there's no sun and everything is still and calm, that's what the air looks like. It's just a smooth blanket sitting above the ground. But as soon as Mr. Sun comes out and the ground starts warming up in uneven ways, something very interesting happens, and I'll show you what that is. Just take away this piece here, and you will find that if we were to be able to see the air, we would get a bubble forming. And this would go right up into the upper reaches of the lower atmosphere. There you go. So what's happening here is this sun is warming up the brown area. So let's just put a little bit of heat coming off here. The darker part of the surface of the earth here is getting warmer than the lighter coloured parts. And that means that the air above it gets warmed as well. If you've got a heat source, the air around the heat source gets warm. So the air gets warmed here. And what happens when anything gets warm, think a hot air balloon, warm air expands and it rises. So as you can see, this air is starting to rise, creating this big bubble. There's your thermal. That's what a thermal is. It's warm air that's expanding and rising. So naturally, if you're flying along with a model and you hit this, you'll go up. Sounds easy, doesn't it? Now, that's what a thermal is, but there's actually a little bit more to a thermal, which I'll explain perhaps in a later video, which is to do with the rotation of a thermal and the Coriolis effect, and the fact that it's actually better to fly against the direction of rotation than with it, for reasons, as I say, I'll explain in a future video if required. But what I want to do initially is look at how can we identify a thermal. How can we tell where they are? Because you can't necessarily see them unless they're catching dust or something, or bricks or little children or toolboxes and sucking them up. How do you know where a thermal is? Well, there is, of course, some visual clues. If you see birds like hawks or vultures circling in a circle, they're probably in a thermal because they're lazy, just like the rest of us. They'd rather just circle in a nice warm current of air than to have to flap their wings continuously to stay aloft. So they will often circle around thermals. So look for birds that are circling. That's not a lot of use if you're doing DLG though, because they tend to be up really high and you're right down on the ground. So if you're down here, standing, trying to fly your DLG, here we go, and you've got your DLG on one hand. Let me see if I can draw a model aeroplane. There's your DLG and here's your radio transmitter in the other. How are you going to detect a thermal? How will you know when to throw, where to throw? Well, here's a little tip that, when you think about it, it's pretty obvious, but a lot of people I've met trying to fly DLGs are completely unaware of this. Right, here we have the air rising, and I'm going to draw some arrows so the air's going up. This is our thermal, right? Now, if the air is going up, obviously air has to come in from the bottom to fill the gap, otherwise you'd end up with a vacuum here, and all the little tiny creatures would suffocate. but that's not what happens, is it? You get a low pressure area here, so the air around is higher pressure. So what happens is you get a bit of a wind. A bit of a wind actually blows in towards the thermal from every direction. And if we were to draw, can I do this? Yes, I can, I've got enough room. If we were to sort of look and say we're looking down on things, and here's the thermal, let's say it's a round thermal like this, then the wind blows in from all directions. Remember, we're looking directly down on this now, because it's filling up the low pressure area created by the fact that the air is rising away from the earth. More air has to come in to fill the gap. So if you're standing here and you feel a breeze, well, if it's a calm day and suddenly a breeze pops up, you know there's a thermal around. But how do you know which way the thermal, whereabouts is the thermal? Well, obviously it's blowing towards the thermal. So if you're standing and you feel a breeze on your face, then the thermal is behind you because the air is rushing past you to get to the thermal. If you feel a breeze on the back of your neck, the thermal's in front of you because it's rushing past you to get to the thermal. Simple as. So you can use that. And of course, as the thermal gets closer, the wind speed will actually tend to pick up a bit. So the stronger the breeze, the closer the thermal is. And if you time it properly, if you're standing, let's say you're standing here, let's look down on you as well. There's your little feet and your little arms and your plane. There you go, and your transmitter. If you're standing there and you throw your model at the right time, you can fly straight into the thermal and away you go. Easy peasy. So that's how you can tell on the ground. Of course, if there's a bit of a breeze, if you're feeling you're staying there and there's a fairly constant breeze, and then suddenly that breeze intensifies, well, that's the same as the thermal coming closer will cause the wind that's going with. So let's say, I'll try not to confuse you too much, but let's say we have, and I'll have to rub something out because I'm running out of space this time. Let's remove our little vertical view. Let's say there's a general breeze in this direction. Well, obviously, if you're standing here and you feel a breeze on the back of your neck, there's a really strong thermal. If you feel just a gentle breeze in your face, constant, there's no thermal. If the breeze blowing on your face increases, then the thermal is over here because it's blowing past you to get to the thermal. So you can work it out for yourself. You know, you can work it out. So basically, yeah, the wind will always blow towards the thermal. Use that because it means you'll get a breeze, or the breeze will increase or decrease in intensity as the thermal comes nearer. So there you go. That's easy peasy. But now you throw in your model. How do you know when it's in the thermal? That's one thing that a lot of people don't understand, is how to detect when you've actually hit the thermal. And it's actually not too hard at all. Let's take a look. Let's say you've got a model, and let's say it's flying along like so. There it is. We're looking at the front of it. It's flying along. If there is a thermal, I hope I've got enough space. Yes, I do. If there's a thermal here, and you fly past it, what's it going to do? It's pretty obvious. It's going to kick up this wing. This wing on the glider will kick up because the lift will tip it over. So your plane will actually bank away from the thermal. Almost inevitably, if you see your plane bank, it's flying along smoothly and it starts to bank, it's turning away from the thermal because the thermal will be lifting a wing. So it'll turn away from the thermal. So what should you do? Well, turn back into it. Simple. But there's two schools of thought there. And again, I'm going to have to erase some of the board, but I'll do it with a jump cut. How quick was that? Right, here's our thermal. We're looking down on it from above, and here is our model. And there we go. It's a crap drawing of a model, but you know what I mean. And we're flying along. What's going to happen here is the thermal will lift this wing, so the plane will bank this way. So if we did nothing, the plane would actually turn away from the thermal. And if we didn't notice it, we would never know the thermal was there. What a shame. All that lift going to waste. So what most people do is they actually, as soon as they see the wingtip bank, they will start a turn towards that and try and get in on the thermal, around the edge of the thermal where the air is circulating in the thermal. It's no good just flying through a thermal because you go up and you go down again. You want to fly in the circle, which means flying a circular pattern. You have to fly circular. The closer you are to the ground, the tighter that circle will probably be, because if you look at a thermal, they're actually a bit like a tornado. They tend to start out really small down on the ground, but as they go higher, they get broader. And the air tends to circulate. You've seen dust devils, little willies, you know, the dust spins around. That's a thermal that's actually touching the ground. And what happens is, due to a thing called angular momentum, as the air rises, that spinning is actually throwing the air out as it would, you know, centrifugal force, centripetal force. When you spin something around on a string, it tries to throw it to the outside. Well, the spinning air gets thrown out, so you end up with a cone that grows bigger. And as it goes bigger, the revolutions drop. It's like an ice skate, you know, they hunch up, they go really fast, open their arms up, and they slow down. Same thing, as this gets bigger, the speed of revolution gets slower, fewer RPMs. So if you hit your thermal down here, you're going to have to turn quite tightly to stay in it, but as you go up, you'll be able to turn far more bigger diameter turn. And that's better because you're losing less because you're not banked so steeply, so your glider is more efficient. So that's why the higher you are, the easier it is to thermal soar. If you're doing DLG, every extra meter of height you get out of the launch makes it so much easier to hook and retain a thermal and go up. If you only get up 5 meters, well, it's really hard to do thermal soaring with a DLG. If you can get 15 meters, 20 meters, 30 meters, then it becomes easy to sustain yourself and get up and get into the areas here where it's big, because it's very easy to miss a thermal when it's small on the ground. Get up here, you've got far more room for error. You know, I mean, if we look at our diagram again, if we were flying great big circles here, we could miss the thermal completely. It might be right in the middle of where we're flying. So it's important that we try and judge the diameter of the circle, and you can do that because the model, of course, that wing will keep tipping up. So if you were to miss this thermal, let's just get rid of some of this unwanted stuff. If you were to turn here and miss the thermal, then you wouldn't notice, the model wouldn't go up and it wouldn't be fighting that turn because it wouldn't have rising air under the wingtip. So what you would do then is turn back to the original position, and you'll find that you'll fly into the circle and it'll probably go up, and then once it starts going up, then turn left or right to try and stay in it. It takes a bit of experimentation, you're figuring out where it is, but you get a feel for it. After you've done it a few times, it becomes quite instinctive and you just know when to turn and where to turn. Now, this is one way of catching a thermal once you notice the wing go up, but there is another way. Because if it's a very, very small thermal, let's say we're flying along and I'll do a small thermal. It's very near the ground. Here we go, dust devil almost size. And we fly along. Actually, I'll move it over a bit because we want to get it under the wing, don't we? So it's around here. So we fly through this thermal, our wing kicks up, and we do a fairly tight turn. We could still miss that. So what some people do, and I do it sometimes too, depending on how high I am and how much the wing kicks up, and which wing kicks up, sometimes what I'll do is, instead of turning back into that, trying to do a really tight turn to get into that thermal, I'll do a much more leisurely turn the other way and come in here. That enables me to also gauge the size of the thermal better, but it's really just something that, you know, you need to practice and try it for yourself. Simple, but recognizing the thermal first on the ground, the wind direction will tell you, and in the air, the rocking of the wing, or even if the model pitches up. That's a bit of a, you've got to watch, that's a bit of a trap for young players. Some people see the model pitch up and think, whoa, got lift, but sometimes it's just a gust of wind, because remember, all around here, the wind is blowing in. So it's very easy if you are flying and you come around here, I don't know, say you do a turn into the, here we go. If you do a turn around here and you come around there, this wind blowing in here can actually cause you to balloon up a bit. It's not lift, it's just the wind blowing into the thermal, and you've turned into it and you had a bit more speed on than you realise, and up you go. So yeah, it's just experience. The best thing you can do with thermal soaring, this is the key ingredient to thermal soaring and getting it right, is this. Practice. No, it's a verb. We want you to practice. S for the verb. Practice. There you go. That's the most important thing. The more you do it, the easier it is. So there you go. That's some of the basics, you know. What more can I say? Now, as I said, there are some other issues here, which I will explain because this video is already long enough. I wanted to keep it really simple. The eyes are glazing over in the back of the room. But as you know, when you open it or fill a bath up with water, pull the plug out, the water goes down the plug hole, it doesn't go straight down. It spirals in a whirlpool. And it's the same when you have a thermal, like so, let's say it's a thermal, the air doesn't just come straight in and go up. We're looking from the top, doesn't go straight in and go up. It actually spirals up. So it will come in like this, and the whole thermal itself will be rotating, a bit like a whirlwind. And again, the wind comes in here, wind comes in here. So it's a little bit like a tornado, which means inside this column of air, there's actually a rotation. At the bottom, it's very fast, as I said. Near the top, it virtually disappears, because at the top, let's just draw another diagram. I'm going to show you what happens at the top of a thermal, because people say, oh, there's a thermal under that cloud. What do they mean? Well, let's draw the ground. Here's the ground there. And let's say we have a thermal, and I'll just draw it as a spiraling. What happens is at the top of a thermal, I need another colour. What have I got? I've got heaps of colours, but I'm going to use red because I can. Probably doesn't work. It does work. Okay, at the top of a thing, you quite often see something like this. A big fat cloud. And what's going on there? Why do you often get so much lift under a big fat cloud? Well, what's happened is this air is rising, and because it's warm, it carries a lot of moisture. When it gets to, as you go up in altitude, the temperature drops. That's just one of the laws of physics, and there's so many degrees per 1,000 feet. I forget what it is, but as you go up, it gets colder and colder and colder. So eventually, this warm air hits an area where it's so cold that the moisture in it starts to condense into droplets of water. The water vapor condenses into droplets of water that creates a cloud. So as the air goes up, eventually it turns into a cloud, and voila. Now, one thing is, you don't see the cloud spinning around because at this stage, usually the rotational speed is so low that it might as well be still. But down further, you've got that rotation to consider. I will talk about the Coriolis effect, about how to fly in thermals to get maximum lift or maximum performance, because going one way is better than going the other way, believe it or not. But that's for another video. That's thermals, that's the basics, that's the simple stuff. In respect to DLGs, just before I go, as I say, altitude is your friend. The more height you get out of the launch, the easier it is to get into the broader part of the thermal where you don't have to be as accurate with your flying. So you need to practice your launch, really get in there and see what you can do. In that respect, I've got two DLGs I fly a lot. One of them is the 950mm Hobby King one with the covered wing, built up wing and a plastic pod on the front. And that is heavy, but it's quite small. I get a lot more altitude with that than with the 1 meter Kevlar fiberglass DLG, which is really, really light, because the little one is heavier. It's got more inertia and I can get it up higher, but once I'm up there, it doesn't glide as well as the big Kevlar one. So picking the right machine for the day is good too. If I have really, really light lift, because sometimes you just get what we call light air. Light air is when, okay, this was going to be a short video, wasn't it? But it's dragging on. Never mind, something else you need to know though. Sometimes you get thermals that are incredibly big but very, very weak. So if we drew a thermal like this, and you can see there's a bubble here, but it's a really small bubble. Well, it's not small in terms of its height, but it's small in terms, not small in terms of its width, but it's small in terms of its height. So everywhere under here, this can be a really big area. There's a gradual rising of the air. And sometimes it's just enough to keep your plane in the air. Those are the best conditions. I love those conditions. So any mistake, you lose too much height, you land. If you do it dead right, you can stay up at probably 2 or 3 times head height for minutes at a time. And with light air, you want an aircraft that has a really good, really low rate of sink. And it doesn't matter how high you go here, the lift is still so light. So you want an aircraft that's really light, and you don't have to launch it that high, because going higher won't give you more lift, and it won't. And because this is so broad, you won't be. It doesn't matter if you. There's nothing to miss. The thermal is so big, you're always inside it, in line of sight. Those conditions are great. So I would use my Kevlar fiberglass DLG and that, or my Kevlar carbon DLG. For conditions when I've got small, tight thermals, I use my other DLG because I can get more altitude and get into the wider part of the thermal and fly that. So different craft for different days. I don't do competition DLG. I'm not a competition-oriented guy. I like to have fun, not pick over bloody fine points of rules and stuff like that. So yeah, I just throw them in the air to have fun, and they always come down. So I've never lost one. There you go. Simple stuff. Now, if you've got questions, as invariably you will, I hope, because hopefully you're still awake in the back, then fire them at me and I'll do my best to answer them. In the meantime, I hope this is what people were looking for, hope what they're asking about, and I will now clean the whiteboard and get back to the bench, because I've got some more builds to do for Fixed Wing Friday. Oh, before I go, I forgot. I don't know, I've never been taught any of this. This is stuff I've picked up myself, and I've done a bit of reading online. So if you're a thermals or a guru type DLG fancy guy that does everything dead right and I've made mistakes, tell me. Put it in the comments, because I'd like to learn where I've gone wrong, if I've gone wrong. So there you go. Please enlighten us if you know better, because lots of people will know better than me on this subject. Again, bye.